Hello everyone, welcome to the 11th day and the 11th video of this series. So today we are not actually going to change any ranking formula. Yesterday we added BM25, so our search engine is already giving way better results. Let's just run it once before we begin. All right, so we have the results along with the score as well. Okay. Um, this video is mostly about explainability. So right now you will see that a search result does give a score to us. And for this demo, let us use our demo one so that we can actually start small and then apply the same method to our whole app. So you will see that we have scores here, here, and here. So this tells us the score and which document has won, but it actually does not tell us why this document has won. So obviously you can look at the data and figure that out, but we would actually want to know that like in a quantitative manner that why it has won. So day 11 is all about ranking explainability. It's very important you know how to do this because when you are actually implementing something which has search, you would want to know where your document stands and why it stands, like all the different parameters which are involved in ranking your documents. You would like to have deeper insights into it rather than just have an abstraction of it. So in this video we're trying to see if we can add which terms have matched, how many terms each term has times each search term has appeared, how much contribution is there of each term to the final score, and which query terms are missing. So this like we have the score over here. It does look good, but it is not for debugging, not very good for debugging. And now, just to do a recap of the previous video, we implemented BM25, which has this formula. So the final score is basically the contribution of this first term. Like it's basically the contribution of the first term plus the contribution of the second term, and so on. So naturally, we have an explainability in BM25 because all of these individual words which we are using here, or the individual terms which are there, these already explain something on its own. Um, if we only somehow export how much contribution is there of these terms, we will have an answer for explainability. So yeah. So let's get to the coding part. Current BM25, when we are doing our BM25 over here, so this build BM25 index we have here, over here we are doing all this calculation. So what if I first take all this calculation out of here into one separate function, which I'll define as calculate BM25 term contribution. And in here what I can do is I can take in these parameters. So the parameters here will be term frequency, the IDF. I should have the IDF. Yeah, the already calculated IDF, the document length, average document length, um, the K1 parameter, and B. Okay. And what I will do here is instead of all this calculation, I can simply cut it from here, paste it here, and over here just call calculate BM25 term contribution, and I can simply give all of these values from here to this function. So calculate BM25 okay, I can copy this and paste this here. Fine. So let's just start writing this function now. So this what it returns is a float to us, and what we can do here is, yeah, first of all let me indent it a little bit. And this length normalizer, I can write a function for this, calculate um, BM25 length normalizer. And what this needs is just the document length average document length and the B. So now I will cut this and I will write another function def calculate BM25 length normalizer, which will take in this. This will return me a float, and yeah. So we have this calculate BM25 length normalizer function, and I have to do one condition here so that I do not divide things by zero. If average document length is less than equal to 0, simply return 0.0. Otherwise, I can just return the calculation I have here. And what I need to do is I can copy this one, paste it here. So this function normalizer BM25 length normalizer. Okay. So I have my BM25 length normalizer function, and it takes in the document length, the average document length, and B. And this one, this saturated TF, this one also I can write a function as calculate BM25 saturated term frequency. And what I need to pass is simply the term frequency, the length normalizer, and K. And I will, as usual, cut this, the K1 actually. And wait, let me paste. Okay, let me paste what I have cut from here. And what I can do is I can copy this, do a def of this, take this, paste it here, K1, and just return this. Return this whole value, and this is going to be K1. So we have our BM25 term contribution over here. So we have the saturated TF, and we have this as well. So we can just return this part, and yeah, let us just return this part, and we are using it. Build rank inverted index is not defined. Hold on. Is it actually okay? It was an indentation issue. Okay, so we have our build BM25 index as well. We have the contributions also. So we are taking the contributions from here. And what we need to do next is define a search function, which will be define search BM25 index with explanation. And this can take in the query string the BM25 index, or let me just copy it, man. This is going to, so this is the build search BM25 index. So this is going to take these parameters, but it is also going to take the file data, which is basically a dictionary of string comma string. It is going to take the K1, which is a float, and its value is 1.5, and it is going to take B, float with the value of 0.75. Okay, and this is going to return me a list of dictionary. So what this is going to do is simply going to do ranked docs equal to, first it is going to call the original function which is there, so query comma BM25 index, and now when I'm returning it, I will call another function explain BM25 result. So let me first build this explain function. Define explain BM25 result. So this explain BM25 result, this is going to take the query. We can take the query, the BM25 um index. Okay, the query, the BM25 index. This is also going to take the file name, which is a string, then the BM25 index, then the file data. The file data. Okay, file data, and these values k1 and b. And what is let's just return a dict over here. So query tokens equal to tokenize with stop words for this query, comma stop words. We already have used this a lot of time. Let me build the index. So ranked index equal to build bm25 index. Just give it the file data. It will build the index for us. Document length equal to calculate document length. This is just going to be the file data, and um, average document length, calculate average. Good, good. It is already coming for us. So the document length, it is going to be the file data. Okay, and total docs equal to the length of file and data. Document length, we need, it will be document length dot get, like the length of that specific document, and if it is not, then just take 0. Match terms, we will also show the match terms and the unmatched terms. Okay, and the raw score, so raw score equal to 0.0. All right, so for each token in the query tokens, document counts equal to ranked index dot get. We have, so from that ranked indexes, I'm going to get the token first. So the token, the value for the token, and now term frequency and documents is there in that value. So sorry, frequency, comma. So what we can do is term frequency. Let's just get the term frequency document underscore counts dot get. So for that file name, what is the term frequency? This should be 0 here, and if the term frequency is less than equal to 0, just do a unmatched term dot append token. So the that specific token, it is not matched. All right, continue. And the document frequency, it will be the length of this document count. So how many documents has been matched against that particular token, and the IDF. Now we need the IDF. Uh, we need the saturated TF, and we can then define the contribution. So for IDF, we have a function. Let's do the saturated TF. It's here itself. So calculate this along with the term frequency, the length normalizer. Okay, we need to make this length normalizer also. So what I will do is term frequency less than 0, TF equal to this, IDF equal to this. So IDF equal to calculate, there will be a calculate BM25 IDF, total docs, and the document frequency. So I have this. Now let's create this length normalizer equal to calculate BM25 length normalizer. This is going to take the document length, average document length, and B. So I should start typing here. So document length, comma, average document length, comma B, and we have the saturate TF as well. So contribution now. Contribution, what I can do is from this BM25 index dot get that token. Otherwise, do a get of this, then get the file name. So now from the token, I have the file name. So this should be something like the token. Then I go to the file name. So over there, I have a score. Um, and if that, okay, let's take a pause for a moment. Um, so if contribution is none, if the contribution from these terms is none, so it is basically contribution equal to IDF into saturated TF. Um, and now we can do the raw score. So raw score for all of this will be just contribution, and this match terms we haven't like added anything yet, so we can just append to this a dictionary which says that the term is this token. We can say the let me just start copying things. So what are the important parameters we can represent? I think term frequency is something which will help people. Term frequency, there is document frequency, document frequency, the IDF, IDF, and the document length also should we give? Let's just give it, man. Okay, the document length, average document length. Let's give the length normalizer also. So length normalizer, and the average document length. Okay, and the saturated TF, and we can also give the contribution saturated TF, comma, and give the contribution as well. Okay, so this is going to give us everything we can possibly get. Just return. Now when you are returning it, so this parameter which you are returning, it will be for that file name. Um, like how much contribution has been done for this specific file. So we need to return the file name, obviously, file name. We need to return the final score that is been generated. This will be obviously the raw score. We need to give the mashed terms. This will be mashed terms, unmashed terms, and we need to add a score explanation. Let's just give it like um, BM25 score is the sum of each mash query term contribution. So mash term has all the data I need to actually explain me like for explainability. So it says it is not closed. I missed a comma. Okay, it is looking good now. So now we have to use this in our main function. Explain BM25 result. Okay, and this is actually being called by this search BM25 results with explanation. We have to import it over here. We have imported it, and what we can do here is basically um, so now our explanation result, it's a bit different. Like it is not like the normal result which we have. So I can actually write a function. So print explainable result where the result is a dictionary. Just let me see if I can copy some things. Um, so I can print the file name. So just print the file name from the result file name. Printed the file name. We also have the final score, and we have the matched terms. This will be final score, or do we have score here? This will just be score. And then we have for term in result match terms. What we are going to do is we are going to print. So let me open this here and F. So first of all, let's print the term. Uh, so this will be, or maybe I can just like fast forward this part because it's just printing the terms. Hold on. Okay, so I have added this print statements here. So for each of these matched term, print all of this data which we populated from here. And if there are unmatched terms, print those as well. Print the contribution total as well. This is actually going to go here. And now we have this function also to print it. And now we just need to call. So I will actually add a function for this demo. So show demo with BM25 explanations. BM25 build the index. Let me delete this folder, although it is not used here. So what I have here is basically I can do explainable results equal to search BM25 with explanations, and just copy these, just paste it. Demo query BM25 index, and also I need the documents for explanation. I think I have it in the functions. Yeah, we have the file data. Now enable results. So here I will call this function. We'll comment this and let's see what it does. So okay, there is an error. Mm, in search BM25 line 125. Okay. So if file name in the search dot items, you have this. Okay. So search BM25 index. If weight is less than equal to 0, I'm returning it. File name comma weight. Uh, Weight. If this file is not matching, I'm just giving it. Mm, let's see where we have, like, how do we have this bug? We're building the BM25 here, and BM25 is being built here. Um, so we have this function here, search BM25 with explanation. we have this plain BM25 result. And okay, let's see this function once. So, oh, I'm not returning anything, my bad. Nothing. Okay, I'm not printing it actually. Just print the explainable results. Uh, okay, so this is first 25 with explanation, and we have this is returning me a list of dictionary search beyond 25 with explanation. Uh, okay, so result for result in explainable results generator object. Oh, I'm not calling the function here, my bad. So this explain needs query file name BN25 index file data, right? So let's just give these values quickly. Query file name BN25 index, and what did it want? File data. Query file name BN25 index, and let's give it the file data. Uh, we have the file data. Next, it is asking for the K1 and B. So K1 and B. We have given K1 and B as well. Okay, so we need, like, in this ranked docs, we actually need to call this. So for um result in ranked doc, and this result here, it is going to give me a list of dictionary. So for each dictionary which is coming from here in this result, I will have a file name, I believe. So this should work. No, still an issue. Let's see what the error is. Calculate. This is expecting a dictionary of string and integer. Oh, file data is actually a string and string. So we need to pass document length. Once I've and we have missed returning something again. Show demo with explanation. So search BM25 with explanation. This is returning me this, and this one is returning me this value. Hold on. Okay. This last print. Oh, I actually have. Uh, we have this in line 122. Oh, and in here 146. Uh, oh, what I can do here is basically for result in explainable results, just simply print the result, man. Print result, print this into 50. Now we have the result. So now what we learn from here is that for each of the parameters, now we have a proper view of how much which term is contributing, and you can see, like, these are the match terms, and this is the IDF portion which is contributing. This is the document length, average document length. This is how much the length normalizer is contributing. So Now try to correlate this with the thing we learned in the previous video, which were the constants k1 and b. Those come into picture now because with the help of those constants and this information, you can tweak your search parameter, search query actually. So now you see we have the relevant NLP retrieval at the top, the keyword stuff NLP at the second place with the same search pattern, simply because you will see that over here we have the length normalizer as 1.375. The saturated TF which we have, it's much more than this first one, which is actually contributing negatively to its ranking. So this is how explainability will really help us, and this helps us in debugging, checking whether one query term is dominating or not, seeing which queries are better if there is some stuffing like we did with the keyword stuffing in the last video. So it's actually very easy to explain with BM25 also because it is term based. So keep that in mind. And with this, we end the video. Thank you for watching till the end. See you in the next one.